Hey, what's up, everybody? You know who I am. It's Mr. C, and you know where we are. It's STEM with Mr. C. Hey, coming back to you with an awesome science lesson for this STEM video, and we are going to be filling up balloons with fruit. Okay, we're not actually going to physically fill up the balloon with fruit because really, where's the science in that? Other than watching the balloon stretch out and possibly break in my hands. No. We're gonna fill it up with the gas that comes from mixing fruit and baking soda. Now, many of you probably see my vinegar here. Many of you have mixed vinegar and baking soda together. And you know what happens, right? It goes fizzes everywhere. You've probably made volcanoes or seen volcanoes before. Really cool. If you were in my TK or kindergarten class last year, we did fizzy rainbows with baking soda and vinegar and a little bit of food coloring. A lot of fun. And then in our kindergarten class, we actually did it before our elephant toothpaste experiment. It was really cool, right? Now, how are we gonna get the same reaction with fruit? There's no vinegar in fruit. Have you guys ever eaten a grapefruit or a lemon or an orange? Did you taste vinegar? No, there's no vinegar in there, but we're going to figure out how that works, why it works, and we're going to see it live here. Now, don't be concerned about all the materials here. You don't need all of the stuff. I like to come over prepared, but let's talk about what you do need. I do recommend, if you've never done it before, vinegar and baking soda. Vinegar is a lot of fun. Also, a lot of great uses. Cleaning windows. You can put a little bit in your dishwasher, get rid of those stubborn hard water stains. Really cool. You can also use it to clean your bathroom and get rid of the hard water stains. A lot of good uses of vinegar. You're gonna need baking soda, of course. I recommend at least 1 or 2 fruits, right? You can do 10 fruits, I don't care. But at least 1, 2 is really cool, right? So I'm gonna go with a lemon. I have 2 lemons here. I'm gonna go with a grapefruit. You can go with whatever you want. Apples, pineapples, bananas. Well, on second thought, you gotta get the juice out of the fruit. I don't know how you're gonna juice a banana. Maybe not a banana, maybe something else. Maybe stick with apples or pears or something where you can squeeze the juice out of. Okay, I also recommend, now if you wanna get really scientific with me, I recommend like measuring cups and measuring spoons, right? Why? Well, we can see which works the best, right? Which, is it vinegar and baking soda makes the biggest balloon? Is it grapefruit and baking soda? Is it, it doesn't matter, right? But we're gonna keep the results consistent, not the results probably won't be consistent. We're gonna keep the materials consistent. So we're gonna measure out exactly how much vinegar or juice that we need, measure out exactly how much baking soda. That way we can get a consistent result, right? Because if we put, 1 tablespoon of baking soda in here with vinegar, but then we put 4 tablespoons of baking soda, it's gonna be kind of hard to figure out, which one works the best. Now, if you don't care about that, you're some of my younger students, you're like, Mr. C, I just wanna see something cool happen. Totally fine, go for it. You don't have to measure it. But I do recommend it because it is something a good scientist always does. Okay, so I do have my measuring spoon. I'm gonna go with a tablespoon. And I have 2 different things. They both measure out the same. You're gonna need balloons, of course. I have 3 balloons because I have 3 little flasks here. Speaking of flasks, I'm using my little Erlenmeyer flasks. You don't need to use these, right? Any sort of bottle will do, like a small water bottle, disposable water bottle, small Coke bottle, one of those 20-ounce plastic bottles. I'm using the Erlenmeyer flask, 1, just because you can kind of see clearly what's going on. It's nice clear glass. And 2, look how cute these little things are. Oh, they're so cute. And there's little...
So that's how it is in their family.
Anyway, sorry. Yeah, that's really it. Funnels are great. You don't need them. I use them because my hands shake because I drink way too much coffee. I'm not going to stop drinking coffee, so I use funnels. And then to cut your fruit, obviously a knife and a cutting board. If you're some of my older students, that's fine. Just remember to be careful with the knife, please. Younger students, please get your parents' help. Great knife safety tip: whenever you're cutting, always remember this little rhyming thing. Like a ship going out to sea, cut away from me.
You got it, dude.
Makes sense, right? Because if you cut into yourself, you're gonna cut, it's gonna hurt. You don't want that. Okay, I think we got everything. All right, so if you guys are ready to get this going, then we're gonna zoom in and we're gonna see exactly what's happening here right now. All right, here we are. So first thing we're gonna do, right, I've got all my materials set up. You guys got a nice front row view right here. I've got my first Erlenmeyer flask, and what I'm gonna do is I'm gonna put vinegar in here. So I wanna measure, and you'll see this one, it says approximately 40, 60, 80, 100 milliliters. And that's just because it's just kind of, you can't always get a great measurement with these. So I'm gonna use my little Anchor Hawking kitchen tool here, and I'm gonna measure it in milliliters. Milliliters are commonly used in the scientific community. So I think, you know, I'm gonna go with milliliters. So we're gonna fill it up with 30 milliliters of vinegar, okay? So now I don't really have to, you know, use a funnel right here, and I already spilled, look at that, spilled. So I'm gonna fill it up, and once we get to 30, right, as close as you can, and that's about 30 milliliters right there, okay? All right, so that's good, and then let's go ahead and, I don't need the vinegar anymore. Let's go ahead and put our funnel, and then let's go ahead and put it in our first Erlenmeyer flask. All right, 30 milliliters. Perfect. All right, there we go. Okay, now I do recommend, once you're done, we go rinse out. If you're only using 1 cup, you wanna rinse this out every time so you make sure you're not contaminating vinegar with the lemon, with the grapefruit. Okay, so I'm gonna go rinse these off, and then we'll be right back. Okay, so I've rinsed this out and I'm ready to go. So let's do our lemon juice next. I put my vinegar, put that baking soda over there. So my vinegar is right here. And I'm gonna keep it to the left just so I know it's right there. If you wanna label it, you can. I'll just label it on the video so you guys know. All right, so now we're gonna go ahead. Let's do our lemons next. So I have a few lemons, 2, just because, you know, squeezing the lemons, you don't get a lot of juice. Usually to make like really good lemonade, it takes like about 15 to 16 lemons, just takes a lot. So what I'm gonna do, and I also recommend, if you want, you can filter this, right? Putting like a little sieve here. I'm not terribly concerned about it, and it'll just add to the excitement and fun. So we're just gonna go ahead and squeeze. And we need to get about 30 milliliters, right? So let's go ahead and squeeze our lemons. And hey, surprise, surprise, it only took like 1 lemon, so 2 halves. Perfect. Okay, same thing. We're gonna put this in our Erlenmeyer flask. Let's go ahead and do that. Now you notice I'm careful about pouring this because I have some seeds in there. I don't really want the seeds in there. And because they're actually more dense than the liquid in here, they're just gonna be in the bottom. You just gotta be really careful. Perfect. Okay, I'm gonna set that aside. And let's do a little cleanup here. Perfect. There we go. All right, now let's go and get our grapefruit. So I'm gonna clean everything again, and then we'll be right back. And here we are, back ready to go. Ooh, look at that grapefruit. I already cut it open. Look at that. Beautiful. Beautiful grapefruit. Very ripe. All right, same thing. This is all washed off. My knife is washed off, my funnel, and my little measuring cup here. Same thing, 30 milliliters. Here we go. And let's start squeezing. All right. Not bad. So and I still got a little bit left here, so I can eat that later. Maybe save it for breakfast. All right, so what I'm gonna do now Same thing, let's get our other Erlenmeyer flask. And lucky for me, I didn't get any seeds in there, so I can just go dump it in there. Perfect. Now, again, I'm using an Erlenmeyer flask, I told you why, but it's nice to have it, I'll show you here, right? It kind of goes up, flutes up like that. It's really nice because then I can put the balloon on and all the gas gets pushed up there, right? Spoiler alert, yeah, there's gas involved, all right? Here we go. So I'm gonna go ahead and get rid of all this stuff. I don't need it anymore. The only thing I really need is my baking soda, my measuring spoon, and my balloon. So I'm gonna clear all this off, get it out of the way so we can get a nice front row view of what's going on. All right, I think we're ready to go. So just to recap, we have our vinegar, we have our lemon juice, and then we have our grapefruit juice, right? Okay, next thing is gonna be interesting, and I'm gonna push this back a little bit. And now we have to get baking soda, and we have to mix it in here and get the balloon on quick. So there's a couple ways we can do it. Number one is doing that, putting the baking soda in there and then fumbling around and trying to get the the balloon on there. I don't recommend that. That's kind of tough to do, and yeah, it's just there's an easier way to do it. So what we can do is I'm going to use a tablespoon. Now this is a really big tablespoon. So what we can do is we can just get a smaller spoon, but I want to use about a tablespoon, which is about 15 milliliters. I want to put a tablespoon of baking soda in my balloon. So let's go, and this is a little big, so let's go ahead and get a smaller measuring spoon now, and boom, just like magic, there we go. So we're going to use 2 of these, and you can see it's a little easier. I'm going to be able to stretch this out. So again, if you have a partner, if you have your mom or dad, grandparent, uncle, it might be easier for you to hold it open like that and then put the baking soda in there, okay? So let's go ahead and try that now. So there we go, there's about a half a tablespoon, 7.5 milliliters. See how well Mr. C can do this by himself. And there's 2. All right. Look at that, not bad, right? Okay, so if I can get my fingers out of there. And without, whoo, there we go. Okay, so I've got my baking soda in there. So I'm gonna do the same thing with the other 2. I wanna make sure I don't spill any. So I'm gonna leave it right there, and let's do the same thing again. All right, let's do that one more time. Perfect. One more time. All right, so I've got 3 balloons done. Minimal amount of spilling, which is a feat in itself. There we go, brush that off. My vacuum will take care of that later. Okay, now the fun part. So let's move this out of the way. And here we go. So let's do our vinegar first. All right, so I'm gonna take my balloon and we're gonna gently put it over the mouth of my flask, right? And so with your soda bottle or water bottle or whatever, same thing, but you wanna keep all of the baking soda down in the body of the balloon. So it's gonna look something like this. All right, so that's nice. Look at that. So nothing's happening yet because I haven't mixed the vinegar with my baking soda. But as soon as I do, let's see what happens. And as you can see, shake it up a little bit. Look at that. We're filling up our balloon with vinegar and baking soda. Now, once the reaction is done, you can always just shake it a little more to make sure it, and there we go, look at that. Wow, pretty awesome, right? Cool. All right, let's see if we have the same results with our lemon juice. Come on over, lemon juice, it's your turn to shine. All right, same thing. Go ahead and put our balloon on there. Being very careful. You don't want to prematurely mix anything. And let's see what happens. 3, 2, 1. Look at that. I'm going to hold it to make sure it doesn't pop off. Woo, look at that. Shake it up a little bit. Woo, look at that. It's still going too. Still going. Outstanding. Wow. That's pretty cool. That's pretty cool, right? Again, you can shake it up to make sure everything's mixed together. Woo, pretty good, huh? I love it. Love it. All right, let's put that over here. And last, come on, grapefruit juice. It's your time. Come on, here we go. Come on, grapefruit juice. What are you gonna do for us? Here we go. Put the mouth of the balloon on there. All right, here we go. In 3, 2, 1. Let's shake it up a little bit. Ho, ho, ho. Shake it up. Make sure it reacts. There we go. It's going. It's going a little bit. It's going. Come on, grapefruit juice. That's all you got? Come on. You got a little more in there. Come on. No. I guess that's it. Oh. But you know what? That's okay, because we did get a little bit in there. I mean, we can see that it's inflated, right? I can push on it. It's inflated, but look at this, right? Vinegar, lemon juice, and grapefruit juice. Woo! Look at that. That's a success right there. That is awesome. All right. So we need to talk about what's going on here. Other than awesomeness is what's going on. Let's talk about what happened here, what this gas is, and why this reacted the way it did. Ooh, very cool. Any more in there? Come on, grapefruit. Come on, don't let me down. No. No, that's it. Okay, let's go back to our studio and figure out what is happening here. Okay, so first up, let me talk about my glasses, right? So I'm done with the experiment. I'm gonna take off my goggles. It's always a good idea anytime you're working with any sort of chemicals to wear goggles, right? I'm not worried about my hands, so I didn't wear gloves or I didn't wear a protective layer here. But definitely your eyes, you definitely want to protect, okay? These are we're gonna talk about why, but it's always good, right, to use that. So what's going on here? Okay, well, first let's talk about our vinegar, okay? Grapefruit, you're over there. Lemon, you're over there, okay? Talk about our vinegar, right? Now, vinegar is an acid, okay? If you didn't know that, now you know, right? The actual chemical name for vinegar is called acetic acid. Hey, pro tip, next time you're at the store and your mom or dad or grandparents or aunts or uncles say, hey, we need to go get vinegar at the store. You say, it's actually, Mom, it's acetic acid. Trust me, they'll thank you for it. Impress everyone with your knowledge, right? But when an acid, right, mixes with a base, right, and our base, and a different kind of base, right, I'm defining it here. Our baking soda is a base, right? And the actual chemical name for baking soda is called sodium bicarbonate, right? Again, same thing, do the store thing. Mom says, we need to get baking soda. You say, well, Mom, it's called sodium bicarbonate. They'll love you for it. Trust me, they will, okay? When you mix an acid, vinegar, with a base, baking soda, a couple things happen. First thing, our gas here. Well, this is called carbon dioxide, right? That's right, the same carbon dioxide that you go, breathe in oxygen, let out carbon dioxide. So that's the same carbon dioxide here. Okay, so when you mix an acid and a base, you get water, so there's water in here, you get carbon dioxide, and you get a salt. Different than your table salt. It's a different kind of salt. Again, for you chemistry nerds like me, I put the chemical formula down here and the reaction It's actually really cool. A couple cool things happen, right? So that's acetic acid, which is vinegar. Well, Mr. Carey, Mr. C, lemons. What? There's no vinegar, there's no acetic acid in lemons, right? No, you're right. In lemons and grapefruit juice, there's another acid. It's called citric acid, right? It's an acid, right? It's a little bit weaker than vinegar or acetic acid, right? Again, for you chemistry nerds like me, there's the chemical formula and what happens down there when you mix citric acid and sodium bicarbonate. Same thing, you get carbon dioxide, you get water, and then you get a salt, right? That's mixed in this water. We call it an aqueous solution. Now, again, because the grapefruit juice is a little bit weaker, it has citric acid, but just not the same as a lemon, right? Which is why when you bite into a lemon, you go, mmm. When you bite into a grapefruit, it's still going to be a little sour, but you may get a little sweetness in there. So it's a little bit weaker, which is why our grapefruit balloon didn't really blow up as much, right? Now, Mr. C, what about an apple, right? Well, again, each of these fruits has different acids, right? Now, some of them have citric acid or different concentrations of it. An apple actually has malic acid, which will react with the baking soda. Again, my chemistry nerds, we have something called the pH scale, right? And that measures how strong an acid is and how strong a base is. Let's go ahead and show it right here for our viewers right there. So there's the pH scale, and you can see in the middle is water, right? And we say that's a pH of 7. Pure water is a pH of 7. It can go up or down depending on the water, but generally we say water is a pH of 7. You can see vinegar there, you can see lemons, you can see apples. So the further down you go, meaning the lower the pH, the stronger the acid is, right? So we go all the way down to like 1 or even closer to 0. Those are some really, really strong acids, right? If I was using those acids, you better believe I'm gonna have goggles, gloves, some protective gear, because those acids will really hurt you. Please don't play around with those acids. They're no fun. If when I see you guys in class, remind me, say, Mr. C, tell me a story about how you mixed 2 acids together and you weren't wearing proper protective gear, and what happened to you. So it's a great story. It's a very dangerous story, and I'm lucky that I didn't get hurt. And I use that story as an example of what not to do, but also ways to be safe with chemistry. Okay, now the further up the pH you go, right, 10, 11, 12, 13, 14, those are bases, right? Again, don't think that, oh, well, it's just a base. It's the opposite of an acid. It's not going to hurt me. A very, very strong base can burn you just as easily as a strong acid can. So there we have sodium bicarbonate or baking soda, but then we can go all the way up to sodium hydroxide and lye, which is a very, very strong base, okay? So when you mix an acid and a base together, you get water, carbon dioxide, and you get a salt, right? Depending on what kind of acid you used. There you go, right? Pretty cool, right? So the pH scale is very cool to look at, and it's also one of the things when you get into chemistry, you learn about acids, bases, how to test for them. You don't always just do the balloon test. There's lots of other ways you can test as well using pH indicators or strips. I'm getting way ahead of myself here. But last thing, the pH, right? Mr. C, what's pH stand for? Well, pH stands for potential hydrogen, right? And that's, again, why, we can look it up, but that just means potential hydrogen and the ability of it to react, with acids and bases together. Pretty cool. Okay, so that is it here. A lot of fun, right? Again, I recommend when you have this, this mixture right here, throw it out. It's safe to dump down the drain. This stuff's fine because they're fairly weak acids. They're not going to do anything. I'll give you one more pro tip. If you have a drain clog, and you don't have any of that strong liquid Drano, and you don't want to hurt your pipes, and the stuff's expensive and it's very bad and caustic, a great natural solution to clean all those hair clogs and pipes, dump some baking soda down there, right? How much? I don't know, as much as you want. I usually do about a cup or two, depending on the drain, and then put an equal amount of vinegar there. So what's going to happen is that very strong reaction generally loosens up the hair and the gunk and everything. It's a great natural way to clean your drains. It's also a lot of fun too, to kind of see it in action. Okay, look at that. Not only do you get some science and STEM and chemistry knowledge, you also get some housekeeping tips from Mr. C. I know, usually you pay extra for that, but this time you guys get it for free. All right, hey, I enjoy doing this with you guys. Always a lot of fun. Hey, so tell me what you used, right? Did you use apples? Did you use bananas? Were you able to juice a banana? I don't know. Tell me what you used and tell me how well it worked out for you. Or send me a picture. Or send me a video. Awesome. I love to see your guys' pictures and you guys experimenting. That's all for now. I'll catch you guys next time for some more STEM with Mr. C.